Hey YouTube, I want to introduce you to my small solar power system. I'm on the island of Barbados, that's in the Caribbean, for those of you who do not know. I have 4 panels on the roof. I can't go up there and show you because I live in an apartment and to get up there and get back down is just too much trouble. So trust me when I tell you I have 4 panels on the roof, 195 watts each, 12 volt panels at 15 amps, and they're hooked up in a parallel and series configuration. It gives me 24 volts, comes down off the roof and comes through those 4 wires that come in through that little hole there that you can see. Then they go into the breaker on the left, that white switch on the left, that's a breaker. I'm trying to get this thing to focus. Yeah, good. 30 amp breaker in case I need to shut off my PV power to do maintenance to the system or anything like that for whatever reason. You never know. From there, it follows that green cable and goes into my Outback MX60 charge controller with maximum power point tracking. It's a good charge controller. I got it way cheap. Right now my battery voltage is at 28.3 volts. 28.3 volts, and I'm doing 613 watts or so, and 21.6 amps. Not bad. Batteries are almost full. From there, let me talk a little bit more about my charge controller. The maximum power point tracking that it has, what that does is it gives me maximum power into my batteries at any given point in time. So it constantly searches for the maximum power point and delivers that to my batteries. The configuration that I have now is 24 volts, so I can put 1,800 watts of power, panels, into my MX60. The VOC on this is 150 volts, as far as I remember. And what my charge controller does is control my charge. Basically speaking, it makes sure that my batteries are not undercharged or overcharged. Undercharged or overcharged, sorry. From here, I have my inverter, which I got from Sun Electronics. See, they put their name on it. Sun Electronics in Miami. I didn't buy it from them directly. I bought it from a guy who bought it from them. I got that at a good price as well. The inverter takes my 24 volts from my batteries and converts it to 120 volts AC, so that my household items can use it. The inverter is a pure sine wave inverter. It is 3,000 watts, 24 volts. It's also a charger, which means I can charge my batteries. I can plug the inverter into the grid and I can charge my battery bank if I need to. I don't have it hooked up for that, but if I need to do it, at least I know I have the option. It peaks, the peak watts is obviously 6,000, because I think it doubles for peak. It has, right now, it has some dip switches here and battery voltage indicating right now that my batteries are fully charged at 100%. From there, the power goes, where the hell does it go? The power leaves the inverter and goes to my power strip, which I have here, which go basically to my loads. I don't have it hooked up to my panel. I was going to do that with this transfer switch that I built. but it was just too much trouble to hook it up, because the thing is, if I'm on solar power, which is this, right? I switch it over to solar power. That means that everything on the house is using solar. And I switch it to grid. That means that everything in the house is using grid power. Now the problem with that is my fridge is on the grid power, and everything else in my house works off of the solar. So it was either or. By not hooking it up, I can leave my fridge on the grid, and the rest of the house is solar. So that's why I haven't hooked it up yet. Basically speaking, I need more panels, and I need more batteries to charge. Well, the panels I have can't charge my batteries fast enough, because the fridge would pull it down. So I'm not going to go there yet, but it's there for when I'm ready to use it. This is the white box there marked kilowatt meter. This is a kilowatt meter. It actually measures my voltage, my output voltage AC, and my amps, my watts. It can tell me the hertz, and it also shows the kilowatt hours. Right now it's on volts. That is amps. It's 1.2 amps. Wattage is 141 watts. I have my TV on right now. Flat screen, 46-inch. That is on most of the time. Yeah, I kind of modified it a little bit. I took the plug off the back, and I put some wires that lead directly to my output on my inverter. These switches, well, you know, the ones on the right, those are the breaker. The box on the right is the breaker. The one that marked charge selection, that comes from the inverter. No, that comes from the charge controller. The charge controller, I can choose which bank I want to charge, because I have 2 battery banks. So I can choose which one I want to charge. The inverter selection switch, I can choose which battery bank the inverter pulls power from. The switches you see here, the one, hold on, right, speaks for itself, right? Fan 1, fan 2, my stuff is all in a cabinet. So fan 1 is those fans. I have them on top of my inverter to assist the internal fan, just to cool it down faster. And fan 2 is this fan right here in my cabinet. It's basically an exhaust fan, pulls out the hot air that my inverter and the charge controller generate. Switch number 3, the one at the bottom, is a light. I turn that on, and the light in the roof, that comes on, so I can see the cabin at night. And this doesn't have the kilowatt meter. It doesn't have a backlight display, so I can see it at night without turning on the house lights or whatever. Multimeter, just do, you know, certain tests and measurements and blah blah blah. My battery bank, this is my battery bank. All mixed up brands, old batteries, different voltages. The yellow batteries in the back, those are the first batteries I got. They are 6 volts. I got them hooked up in a 24-volt configuration, and they are hooked up to these 4 as well. 12-volt batteries, 1 wet cell that you can see there. That's a Trojan, Trojan T1260. That's the only wet cell I have. That's my big bank, and I think these turned out to be 350 amp hours. And this smaller bank here, this is 2 4-power batteries that I got from work, and 2 of these batteries that I got from the gentleman that gave me the yellow ones. and I think together they are 150 amp hours. So I have a total of 500 amp hours or thereabouts, because some of the batteries are not marked. I don't know what the amp hour is. I went online and I tried to find them and guesstimate what the amp hours are. So in my best estimation, I have 500 amp hours. It might be a little more, it might be a little less, I don't know. But that's my system, and it runs my TV, it runs my computer, it runs all the lights in the house, washing machine. I don't have a microwave. It runs my fans, that kind of stuff. So I'm not totally off grid, but I'm almost off grid. My fridge, as I said before, is still on the grid. When the electricity goes off, I normally don't know when it's off, because normally I am on my solar power system, and when the lights go off, the water doesn't work, because we have a pump outside that pumps the water to the apartment, and basically the only way I'm gonna know is if my water stops running. What else can I talk about? Well, I started small. I started with 2 panels, and I worked my way up from there. You don't have to go spend $20,000 or $30,000 or more dollars to get your system set up. Start with 1 panel. Start with a cheap charge controller, which I have. I showed y'all this before. I use this Xantrex C60. Yeah, C60 charge controller at first, and it did a pretty good job. It doesn't have maximum power point tracking, but it still, you know, still did the job pretty good. But my problem with this is I wanted to see what my panels were outputting, and it doesn't have a display, LCD display. You can buy one, but this MX60 came along, and I just thought that it would be better for me to upgrade. So when you're putting together your system, make sure that you keep in mind that you're gonna like it, and further down the road you gonna wanna get more panels, and you're gonna wanna upgrade. So I mean, like, if you got the money, buy a good charge controller. You can't go wrong here, because with this charge controller you could come in at any voltage. I can come in at 12 volts, 24 volts, 48 volts. I can come in at 100 and whatever volts, right? Up to 150 obviously, right? And that would then don't convert it to the working voltage of the batteries, whether it be 24 volts, 48 volts, or whatever kind of voltage you want to use. So get your stuff. This is my stuff. This is my system. I don't want to blabber on, because I really don't know what else to say. I hope this is a better video than I did before. Leave your comments. I would appreciate some suggestions, so I could probably, you know, better myself. I learned a lot from you guys on YouTube. I watch probably most of the videos on YouTube, and I wish more people would get into this, especially where I'm from, in Barbados. Electricity bills here are just constantly rising, and to have energy independence feels really good. When my bill comes in, it reads $6, $0, you know. It's a good feeling. It's a good investment. So thanks for watching, and catch you guys in my next video when I upgrade. Hopefully that will be soon. Take care. Bye.